Hello dear students, friends. Today we will take on Marshall stability test. Very good morning to you one and all. Had your breakfast? Okay. In the last class we were discussing about viscosity, bitumen and completed. We came up to this table. I was saying that the question of following kind, that is, the procedure for conducting penetration test is confirmed to. They will give you 4 choices, different IS code numbers, out of which for penetration test you have to write the correct answer as IS 1203 1978. Such questions will be asked in such competitive examinations. Now we will see Marshall stability test. This is one of the stability tests which is performed on bituminous concrete mix. Bituminous concrete mix. Since we are finding out the stability, and this particular test was developed by name Marshall, who belongs to Mississippi State Highway Department, formulated Marshall stability test, flow test on bitumen, and it is applicable to hot mix design of bitumen and aggregates of maximum size of 2.5 centimeters, that is 25 mm is maximum size. We should not go beyond this size. Is commonly designated or designed by Marshall method. The stability of the mix is defined as a maximum load carried by a compacted specimen at a standard test temperature of 60 degrees centigrade, not 600. 10 should be at power 60 degrees centigrade. If you go 300, 400, 500, 600, it will become ash. So 60 degrees centigrade. The flow is measured as the deformation in units of 0.25 mm between no load and the maximum load. That is the two extremities, no load and maximum load. 0.25 mm penetration units, the deformation is also measured, which is carried by the specimen during stability test. Flow value may also be measured by deformation unit of 0.1 millimeter. The test attempts to get the optimum binder content for the aggregate mix type and trophic intensity. This is the test which helps us to draw Marshall stability versus bitumen. We will be looking after some time. This is the one which is used for conducting Marshall stability test. That's why it is known as Marshall stability test apparatus. Other apparatus and accessories which are used are trowel in order to handle the bitumen for mixing and heating and preparation of mix. Mold in which specimen is to be filled. This is collar. This is hammer. And this is rammer. This is the concrete pedestal which is used to prepare the specimen by using these hammer. This is the specimen after prepared using the concrete pedestal and kept at the position to start the test on it to find out the stability value and flow value, and further density and voids are calculated. Voids in the mineral aggregate etc. are calculated. Bulk density of mix is calculated. We are directly obtaining the value for stability and flow value, that is deformation, using dial gauge. This is the proving ring. The dial gauge is used in order to measure the flow value, which is attached somewhere here. So everything you will see detail in the laboratory. You don't worry. It is included in the practicals as a part of term work, right? Only theoretical part we will see here. Now the test procedure in detail you will be going to do it. However, in brief, the apparatus for the Marshall stability test consists of the following: specimen mold assembly, comprising mold cylinder 10.16 centimeter diameter, 6.35 centimeter height, base plate and extension collar. I have shown in the previous slide with the help of a photograph. Specimen extractor for extruding the compacted specimen from the mold. A suitable bar is required to transfer the load from the extension collar to the upper proving ring arrangement or attachment while extracting the specimen. Compaction hammer having a flat circular tamping face, 4.5 kg weight, 4.5 kg weight, gliding weight constructed to provide a free fall of 45 centimeter. So when we are giving number of blows to prepare the specimen, it should be 45 centimeter or 45.7 in standard textbook. It is given 45.7 centimeter free fall height, 4.5 kg weight of hammer. Compaction pedestal consisting of 20 by 20 by 45 centimeter wooden block capped with 30 by 30 by 2.5 centimeter MS plate to hold the mold assembly in position during compaction. Mold holder is provided consisting of a spring tension device designed to hold compaction mold in place on compaction pedestal. Breaking head consists of upper and lower cylindrical specimens or test heads having an inside radius curvature of 5 cm. The longer segment is mounted on a base having two perpendicular guide rods which just a minute please, just a minute please. Right, where we were? Here, last paragraph we were. Breaking head consists of upper and above, that is also over. The longer segment is mounted on a base having two perpendicular guide rods which facilitate insertion in the holes of upper test segment. Loading machine, it is provided with a gear system to lift the upward direction, pre-calibrated proving ring of 5 tons. Capacity is fixed on the upper end of the machine. Specimen contained in the test head is placed in between the base and the proving ring. The load jack produces a uniform vertical movement of 5 cm per minute. That is also important. It provides a vertical movement of 5 cm per minute, that is rate of movement. Machine is capable of reversing also its movement downward also. Why? After the test is completed, that particular specimen along with the mold is to be removed from the machine. For that it is required to be moved downward also, therefore reversing is also possible. This facilitates adequate space for placing test head system after one specimen has been tested. Flow meter consists of guide, sieve and gauge. The activating pin of the gauge slides inside the guide sleeve with a slight amount of frictional resistance. Least count of 0.025 mm is adequate. The flow value refers to the total vertical upward movement from the initial position, that is zero load, to a value of maximum load. The dial gauge of the flow meter should be able to measure accurately the total vertical movement upward. So the gradation of aggregate which we use, different sieve sizes starting from 20 mm, 25 mm means 25 mm passing, 25 mm passing, 20 retained, 20 passing, 12.5 retained, and so on up to a dust also, up to dust after 0.075 micron is sieve or 0.075 millimeter or 75 micron. 75 micron is equivalent to 0.075 because 75 multiplied by 10 to the power of minus 3 will give you 0.075 mm. Percent passing by weight, grade 1, grade 2. Any one grade may be used. If you are using grade 1, passing 25, retain 20, nil. Passing 20, retain 12.5, 100. Similarly, 80 to 100, 55 to 75, 35 to 50, 80 to 19, etc. The last dust is 5 to 7.5% is also used. That's why the title is given for this. Specified gradation of aggregates for bituminous or asphaltic concrete surface course. Now these are the 5 graphs to be plotted after the test is performed. That means the average value of each of the above properties are found for each mix with different bitumen contents. That means stability, flow value, and then density you have to calculate, bulk density you have to calculate, voids you have to calculate. Graphs are plotted with the bitumen content on the x-axis in all the 5 plots along the following different values on the y-axis. 1. Marshall stability value. 2nd. Flow value. Unit weight. 3rd. Percent voids in the total mix. VV. Percent voids filled with bitumen. VFB. Typical plots of these are as shown in figure. See, in the first case, if you zoom it, you will get it. Marshall stability on y-axis, bitumen percent on x-axis, say 4.5%, 5.5%, etc., etc. In this curve, as the bitumen increases, as the bitumen content increases, Marshall stability keep on increases and then it falls down. Similar to OMC, you recall. In the second graph, flow value, percentage bitumen. As the bitumen increases, naturally it becomes loose. Therefore, flow value also increases. Here it is up to certain extent it increases and then it falls down. Increase, decrease. Whereas here it is continuous increase. Similarly, total voids, total mix or total voids mix on y-axis and percentage bitumen. As the bituminous percentage increases, it keeps on decreasing. Voids naturally will decrease when you use more and more percentage of bitumen because all the voids will get filled up with fluid. Then, similarly, unit weight and other parameter is to be taken and you have to plot the graphs. These are the typical graphs shown. So, however, during practical, you will be going to calculate everything after the test is performed. You will be in a better position to understand how the calculations, etc., will be going to carry out. So, we will stop here. Bibliography, that is reference. Maximum portion is used by the book Highway Engineering by S.K. Khanna and Gesto CEG Highway Engineering, Nemchand Brothers, and IRC codes. IRC codes are also available in our library. If you want, you can go and take and refer. And Highway Engineering, this book also is available in our library in plenty number. Apart from these, so many other books are available. You can refer anyone, but we have referred this as treated as very good standard book. Only the new trends in the material, new technology, etc., were not available in this book. For that, we are providing you reference material also, and we also obtained from internet by downloading, and we got the material and we have prepared the PPT. Okay. Tipayale sir and Wag madam have provided the PPTs for me also for online lectures, and I have rendered the help in making questions for quiz and assignments to both of them. All the questions are different, including mine division quiz questions and assignment questions. Thereby, all the students will get 30 questions on each unit quiz questions and 9 full questions. Each question, first question consists of ABC part, second question ABC, third question also ABC part. Likewise, 9 questions each student will get on each unit. If you prepare for all those questions very thoroughly and deeply, if you study, you will gain good knowledge of this subject. Thank you very much for today. We will continue in the next class with new unit, unit 5. Okay, we'll stop here.